All right. So I didn't get to this last example in notes. I apologize again. So solutions of a linear system in row echelon form. So if you remember, when you have systems of equations, systems of linear equations, you could get one solution, you could have no solutions, or you could have infinitely many solutions. With linear equations in two variables, that would be parallel lines for no solution, intersecting lines for one solution. And then the infinite solution case is where the two equations are actually the same, kind of the same equivalent equations, basically the same line. So every point on that line would be a solution point. In 3 dimensions, 3 equations, 3 unknowns, that's planes. 2 parallel planes, 3 planes, 2 of which might be parallel, and a third plane going wherever. 3 intersecting planes. Think of the walls, think of a room, the walls and ceilings of a room. The wall, the ceiling, and the other wall intersect at a point. That would be 3 planes intersecting at a single point, or infinitely many solutions. This could be 3 planes, 3 of the same planes, or more likely 3 planes that all intersect on a line. It's hard for me to draw that, but imagine you have a corner between 2 walls. You know how that forms a line, the intersection of 2 walls forms a line, and then take a sheet of paper, which would be another plane, and kind of have it intersect along that same line right in the corner. So all 3 planes are intersecting at that line. Regardless, these are the possibilities. So we need to know what these look like whenever we get a matrix in row echelon form. No solution is going to be where the last row is 0 equals some constant that's not 0, in which case you get something like this. That last equation is 0 equals 1. That's false. That's a contradiction. No solution. One solution is our standard problem, where we get this nice 1, 1, 1 in this diagonal. And then z is equal to 8, and so on and so forth. Infinitely many solutions, that last line will be all zeros. So my last equation is 0 equals 0. In that case, we need to look at these 2 equations to come up with that infinite solution set using the parameter t, if you remember that. Okay? So this should be an example of that. All right. Solve the following system using Gaussian elimination. All right. So this is a little bit of work, but hopefully we'll be all right. So my matrix, my augmented matrix, is going to be 1, 1, negative 10, negative 4, negative 1, 0, 7, 5. Don't forget to put spaces in there whenever the coefficient is missing. This is actually supposed to be a 36z. That's a typo. Not bad. All right. So I'm going to eliminate these 2 first. And try to do it on the same step. To eliminate that one, I'm just going to take row 1 plus row 2 and store it into row 2. To eliminate this one, I'm going to take 3 times row 1, add it to row 2, add it to row 3, and store it in row 3. So where you got to be very careful. Row 1 doesn't change. 1 and 2, 1 plus 1 is, or 1 minus, 1 plus a negative 1 is 0. 1 plus a 0 is 1. Negative 10 plus 7 is negative 3. 1. Now here I got to take 3 times the first row, add it to row 3. So 3 times 1 is 3. 3 plus a negative 3 is 0. 3 minus 5 is negative 2. Negative 30 plus 36 is a 6. And negative 12 plus 10 is a negative 2. Now, notice these are all even. I'm going to multiply that row by a negative 1/2 to make the numbers a little nicer for my future steps. So that's going to be 0. Negative 1/2 times negative 2 is 1. Negative 3. Negative 1. You might actually see this, oops. You might actually see this and kind of suspect that something's going on here. And you will be right. You would be right. Actually, that's not a negative 1, I'm sorry. Negative 1/2 times a negative 2 is a positive 1. So those last two equations are exactly the same. I'm going to keep doing row echelon form, though I'm going to eliminate this. I'm going to take negative row 2 plus row 3, store in row 3. So this is going to be 0, 0, 0, 0. When you see one entire row of zeros, that's going to be infinitely many solutions. So now I got to find them. So let's go back into our system. X plus y minus 10z equals 4. And y minus 3z equals 1. So I need to solve one equation for one variable. Let's start here. Y is equal to 3z plus 1. So z is going to be equal to t, and y is going to be equal to 3t plus 1. Now I need to get x in terms of t. So let's solve this equation for x. X equals negative y plus 10z plus 4. But y is 3t plus 1, and z is t. Negative 3t plus 10t is a positive 7t. Negative 1 plus 4 is a positive 3. So x is 7t plus 3. So my solution set is 7t plus 3. Y coordinate is 3t plus 1. Z coordinate is t for t in the set of all real numbers. And no, you don't need to write that down. That is my solution. I'm crossing it out when I'm trying to highlight it and make it look nice. Okay? So that's it. Good luck.